Our next lab is understanding states of matters. As we know, everything around us is made up of matters, and matter exists because tiny particles called atoms and molecules are constantly moving. The way these tiny particles, which made up of every matter around us, are arranged and how fast they are moving determines whether a substance is a solid, liquid, or gas. And these three phases are the most common states of material. There are more states, for example, plasma, but plasma is only seen at very high temperature and pressure, so we will only study solid phase, liquid phase, and solid state, liquid state, and gas state of a material. In a solid, particles are packed together. We can see here, in a solid, particles are packed together closely and held in a fixed position by very strong attractive forces between these tiny particles. Although these tiny particles cannot move from place to place, they can continuously vibrate about their position. As we can see from the figure here, all these particles are moving, but they are not moving from their position. They are only vibrating about a fixed position, and because of this, all the solids have a definite shape and a definite volume as well. Similarly, in a case of liquid, particles still remains close together, but they have enough energy to move past one another. As we can see from here, particles are moving from one place to another. As a result, liquids have a definite volume, but not definite shape. We can see it's changing shape, and the volume, the overall volume remains constant, even though we can see some particle escapes from the liquid phase. Overall, the volume of the liquid remains the same, but the shape is not definite. And in a gaseous state, a particle possesses this particle possesses much more kinetic energy because of this movement of the particles, and because of this high kinetic energy, these particles are widely separated. The attractive forces between particles are relatively weak, allowing and that this allows them to move freely in all directions. And because of this free motion of these particles, gases have neither a definite shape nor a definite volume, and it will expand to fill any container shape and size. And uh, the primary factor controlling this state of temperature, the primary factor controlling this states of a material is temperature, and the temperature is a measure of the kinetic energy of all these particles. As we know, kinetic energy is defined in terms of the mass and velocity of these particles. And as we just explained before, if the particles are moving fast, they have a higher kinetic energy. When heat is added to a substance, for example here, if we add a heat, its particles start moving faster. If enough heat is supplied, the substance can change its states from one, like for example, from solid state to liquid state. Let's see an example here. Uh, Initially, we have a solid neon in a solid form, and as we increase the temperature by adding some heat energy in the system, we can see the particles will start moving faster and faster, and this will increase the kinetic energy of these particles. And if enough kinetic energy sorry if enough if enough heat is added to the system, the we can change the state from solid to a liquid and gaseous form. For example, let's see, water is in solid form. Water is in solid form, and if we increase temperature, it will change into a liquid form. As we can see, the particles are moving little bit freely compared to the solid structure, and ultimately they are moving freely in a gaseous form. So the main contributing factor in determining the state of uh, matter is temperature. As we just said, from a solid to liquid, or from a liquid to gas, we can change matter from one form to another by either adding heat energy or removing the heat energy from the system. For example, here this water is in gaseous form, and if we remove the heat energy from here, we can see particles are gradually slowing down, and ultimately they will be in a solid form. So we can change the state of matter by either adding heat energy or removing heat energy from the materials, thus changing the kinetic energy of the particles. So the first part of this lab is understanding how these particles behave in different phases. You will open the simulation here, and you can see here there's state and phase change two simulations. The first part of the simulation is based on this first simulation. First part of experiment is based on this first simulation. We can see here, you can change the temperature either in degree Celsius or Kelvin scale. You can add heat energy or remove heat energy from the system. You can change the phase from solid, liquid, gas, or you can also change different matter in the simulation. And using all these parameters, you will study the characteristics of different phases of matter. For example, you will study how the shape of solid, liquid, and gas form differ from each other, volume, particle spacing, as well as particle motions. Similarly, you will answer all these different problems based on how all these tiny particles behave when when adding heat or removing heat, or in solid phase, liquid phase, or gaseous phase. And the second part is based on this phase change simulation. As we can see here, uh, in this simulation, on top of temperature, we can also change the volume by by moving this lead up and down, thus changing the pressure of the system. So we will use this simulation to understand the relationship between temperature and pressure. And one thing you should also look at is this phase diagram. As the name suggests, a phase diagram is a diagram where we can see these different phases of a matter. For example, in this case here, water, we can see these boundary lines by this dark black lines. It shows these boundaries between gaseous phase, solid phase, and liquid phase at different pressure and temperature. So as the name suggests, the phase diagram shows us different phases of a matter at different pressure and temperature. One interesting thing you can see from this phase diagram is this point here, called triple point. This is a point where if we can manage the temperature and pressure at this point, we can observe all three phases existing simultaneously. All three phases, solid, liquid, and gas, exist at this triple point. And one more thing here, you can also add some extra particle if you want to add more particle using this pump. You can also add more particles in the systems. You can also add heat in the system, remove heat from the system, and if you want to reset it, you can just click on here and reset the simulation to starting position. So for the second case, you will look at this phase diagram and how this phase diagram will change. You can see a red dot here. For example, let's see, if I add some heat energy, we can see this red dot is moving, and you will explain, you will try to understand what this red bubble is trying to show here, and explain it in the report. And then you will keep the volume constant at some point. For example, if I just leave it here, my volume is constant. So let's see, if I increase heat, what happens to pressure? So the pressure is also changing when I add heat, right? The volume is constant and the pressure is changing. If I remove heat from the system at the constant volume, we can see the pressure is also changing. So you will play around with the different variables and understand what's the relationship between temperature and pressure, given that the volume is uh, constant. And then you will also study what happens uh, when you have more particles at the same temperature and pressure versus fewer particles at certain temperature and pressure. And you will also study what happens when you change this volume of a matter drastically. And once you observe it, you will answer this answer some of these questions, and you will understand uh, what's the difference between different states of matters. And at the end, you will write a conclusion of uh, all the study you performed for this experiment.